So we have Frank Ludolph and Rod Perkins here now, who were both on the Lisa design team. They both have literally decades of user interface experience. Frank Ludolph has gone on to, had worked on Taligent and is now at Sun. Rod Perkins was at Apple and ATG, worked on Spider and 3DO, and is now at Interval. And if everything is working, it looks like it is, we're ready to see Lisa.
Great, thank you. So I'm going to talk to you about the Apple Lisa. And this was a project that was started in 1978 at Apple, and the product itself didn't come out to 1983, so it had a long period of time to sort of iterate over the design and come up with new ways of doing things. And most of you have probably heard of a Lisa, or you've definitely heard of a Macintosh, but the Lisa, as you can see, predates the introduction of Mac by a couple of years. Frank and I were part of the software team, and Frank worked mostly on the system software side, and I worked on the application side, so you sort of get both chance during your question and answer period to ask questions on both. But we're going to use this session to really talk about the design goals behind the machine itself and give you a description of the system, the hardware and the software, what actually went into the box. And Frank will then talk about the user model, how people are expected to interact with the machine. And since this is a demo session, we'll spend most of our time actually just doing a demo and giving you all the ins and outs of what you did to do something with the box itself. And of course, at the end, we'll have a question and answer period. Now, if you're interested in more of the design process that we went through, there was an article that Frank and myself and a colleague, Dan Keller, wrote for Interactions magazine for January '96. And I just refer you to that if you'd like to get more sense of what the process we used in order to create the machine itself and iterate on the design.
97.
97, thank you. So let's just start with the design goals. Our target customer was very much the same as the star. This was office professionals, and we defined office professionals as the secretaries and managers and even the executives to an extent who had a number of tasks to perform every day, but they had to perform those tasks in a highly interrupted environment. That meant they'd start something, they'd have to stop prematurely, go do something else, come back to what they needed to finish, and then that's how they ran their day. Most of these people had really not much computer use. In fact, we look at the office tools that they used in 1978, most of these things were done on typewriters, or as Dave mentioned, 3270 block mode terminals if people were fortunate enough to be hooked to a computer system. So they really didn't have a very rich form of interacting with their machines. What we found during that period is that PCs were still very much used by hobbyists, and the interfaces to them were very suited towards hobbyists. But if we were going to do something that was going to be used for office professionals, we needed to do something different. And if you need a little perspective, VisiCalc, which is the spreadsheet application that really broke through for personal computers, really hadn't even been invented yet when we started to think about what the Lisa should be. So we thought our competition was really going to come from the dedicated word processing machines. In fact, I can remember going to the National Computer Convention in '79 and really looking at the linear word processor because this was one of the things we thought we would have to compete against. But to a certain extent, we used this whole definition of the user to define what kind of capabilities that we needed to design into our user interface and things we needed to pay attention to. So we used that targeted audience to create the qualities of the system. So one of the first things was that we wanted to be quick to learn and easy to use. And we set a design goal which basically said we want to introduce someone to the machine and within 30 minutes have them creating documents and being able to print them. And again, these are those people who have never used a computer before, who perhaps have some allergic reaction to keyboards, whatever it might be. This was the design goal. And that really drove a lot of the design so that if we had a decision to make, we always made it on the part of making the machine easier to use. Now, we also had similar goals for the hardware in that we wanted to make it user serviceable. This was, again, something going to go into a corporation, and they needed to have confidence that this machine was going to be something they could maintain. So the machine itself could be disassembled and reassembled in a short amount of time, and when you plugged it all back together again, you didn't get the blue screen of death. You hopefully got a nice, pleasant tone, and off you went. So the user interface design even went down to what the hardware looked like and how it performed. Now, the user interface itself was designed to be explorable. That meant it was very visual. We had menus, we had windows, everything was modeless. Nothing was very hidden from the users. If they wanted to find something, they could just explore through the interface and discover where it might be. We adopted a philosophy of more see and click as opposed to remember and type. We also wanted to make sure that the things that the people did within their applications, things that they learned, that something could be applied later on in time when they learned something else about the system. So there wasn't learn this part of the system, then learn something completely different in another part of the system. So this whole notion of gradual learning or leveraged learning. And again, since this was going to be going towards people in an office who have never really used a computer before, we thought, well, the system has to be very robust. We can't ever lose data. And it has to be something that people develop confidence in. So a lot of the system design that I'll talk about later went into making sure that the system really maintained itself over time. Support for quick context switching, again, person we're designing for needed to be able to switch from task to task very quickly and very easily. But one of the things that drove us, and especially the user interface side, was that we wanted to make it fun to use. This shouldn't be something that people felt they had to use because it was part of their job or that this was going to be a real problem for them to learn. That it should be fun, and the interface should be fun for them to interact with. So if we move on to the system description, this was using a Motorola 68000, not a very powerful machine, but state-of-the-art at the time, 5 megahertz. We had 1 megabyte of memory. We actually used 64K cards in ours, I believe, as opposed to 16. And some of the later machines, we actually had a 10 megabyte hard disk, but the first machine was actually floppy-based. Display was 720 by 364, so it gives you a fairly high resolution display for that time. And the input device was a single button mouse. And this is an example of where we really didn't know what the best solution would be, and we had lots of discussion about that. The mouse on the Lisa actually was 3-button mice, but we had only shipped a single button version of it, and we would then experiment later if we needed to change that decision. But thinking about just that hardware, that's 1% of today's processing power. If some of you actually have a Pilot or a Palm PC in your pocket right now, that machine is more powerful than the Apple Lisa that we're going to be running our software on today. So the software that was in the machine really tried to address some of the major issues about how the machine would be robust and how we'd operate in this highly interrupted environment. So first of all, it was virtual memory underneath. We had a preemptive multitasking operating system, so it was very easy for things to switch back and forth. We also had a redundant file system underneath, which meant that the file system itself could take simple hits from either bad floppy disk or bad disk blocks and still be robust enough to get the person's data back. And then on top of all of this, we shipped a number of applications. The Lisa had a suite of 7 applications, which if you think of like the Microsoft Office of today, this is a similar kind of applications that you would find there. But the main thing Apple wanted to try and do was create a credible business machine based on its perspective as a PC manufacturer. So we were coming at it from the Apple II perspective. And in that, you needed to have an open software environment. People needed to be able to develop for this machine. Likewise, we wanted to be able to support whatever applications people could come up with for aux, because, again, we were still experimenting with the Lisa and wanted to make sure that we left it open for future refinements. So the Lisa itself ran Lisa software. It also ran Macintosh software. If you hadn't seen a Lisa before, you may have heard it by a different name called the Macintosh XL. But it also ran Unix, it ran different languages such as Smalltalk, it hosted the development environment as well. So the Lisa user interface tried to present a style of interaction that was very close to our target user, and this was the desktop metaphor. And in developing that interface, there was a number of things we learned, but actually were not transferred when the Macintosh was created. And most of those things revolved around what the actual user model was and how the user would interact with the machine. And that's what Frank will describe.
That's right. Okay. As with Star, and probably evolving from Smalltalk, the idea was to use an object-oriented desktop, which meant that we worked with documents and tools. We didn't talk about applications and disk files and processes because those weren't relative to what the user was used to in his environment. It was a desktop metaphor, but we did recognize that it was still a computer, and in a few places we in fact made that quite clear. Things like disks, because they weren't file cabinets, they were disks, and you had to do certain things with them that you didn't do with file cabinets. The interaction style was WYSIWYG, direct manipulation, and importantly, rather different from the Star, it was select and use a menu. So now we'll drop into the demo, and we'll go through these topics in about 20 minutes. Notice the transitional animation. People have been afraid of things jumping out of them since day one. And so we tried to soften that. We didn't want windows just popping up in the middle from nowhere, kind of disconnected from the user action. Here I've opened up 4 different documents. We had different document types. Basically, the background for this group was, of course, an Apple II, separate applications. Each application had a different object type or a different document type. So in this case, I've opened up a calc, a spreadsheet, a graph, a project, which was a timeline type of thing, and a drawing program. One of the things that differentiated Lisa from the Star was that it was what I would call true direct manipulation. You just grab the object and move it. You didn't do a first select, then hit a move key, and then point somewhere, or perhaps drag it, depending on what the case was. And of course, we obviously had overlapping windows, which the early Star didn't, and one of the reasons for doing that was because we had such a small screen. We didn't have a 2-page display. One of the things that we felt that was very important in this was that we have, to use a phrase, pixel-perfect graphics. Most systems, in fact, as far as I know, all systems, but I may be incorrect, at that time, when you moved the window, it left a hole. It didn't refresh the background. You actually had a menu command to refresh the desktop or the other windows that were corrupted when you moved something. In this case, I'm going to move this over to the side. Notice there are 3 windows behind it. And what's going to happen, I'm going to describe it to you because it's going to be happen so fast you'll have to look. The window frames will be immediately redrawn, and then they will fill in, I hope, from front to back. They were supposed to. So you see the content filling in sequentially front to back. At that time, they tended to use painter algorithm, which means it was like laying down paint. When you had overlapping objects, they would first draw the thing in back, then draw the next thing over it, and then the next thing over that. And what you saw was a lot of visual noise, a lot of visual flashing. So the intention here was to eliminate that and create as stable a visual image as possible. And for that, Bill Atkinson developed a update region concept, and this was an application of it. In fact, it was so complete that Bill came into my office one day and said, "Let me show you what I've done." He turned on the machine. He said, "Okay, now draw a figure 8 using the mouse." And you know what that looks like, right? On the screen, nice and uneven all the way around. He said, "Okay," and he pushed a button, and text started smoothly scrolling through it, clipped perfectly at the edges as it went up. And that set a standard for graphics that, in fact, I don't think we've fully accomplished industry-wide yet. It's just something we should be doing all the time. One of the other things that we did here, this is multitasking operating system. In a later release, this is actually the 3rd release that you're seeing, which is not very different in terms of the user interface. As a window was deactivated, it was given a chance to save a graphic of what was in its window. And if it did that, then the desktop manager would use that in refreshing windows. And that meant that we didn't have to swap in a lot of applications and do disk swapping in order to just repaint the windows and back. It did a lot to improve the overall feel. The setup was such that you could start using the front window immediately, even when it had to swap in the other applications, but it was slow and sluggish and very distracting. One of the capabilities, remember we got 1% of the processing power here, folks. One of the things the model in handling documents was that if you were working on them, you could either set them aside or put them away. In this case, I'm going to set this aside, and you'll see it kind of animate back, and it's now actually an icon on the desktop. In order to be able to get a hold of that, we could actually pull down the desk menu on the left, and the desk menu on the left had a list of every icon that was on the desktop. So this is a way of getting at things that were obscured. The ones that are checked, you'll notice, are the windows that are actually open. So if I just click on or select the calc, then this window comes back. To make it easier to, one of the other things I want to mention is that when you activated a window, only one window at a time came forward. Again, this was document-centric, not application-centric. In systems today, you'll often find that when you click on, say, one Word window, all the Word windows will come forward, or one drawing window, all the drawing windows will come forward. That's application orientation. What we did is we wanted to make it simple to work on a graphic and a text document relatively side by side, or at least overlapped, and to be able to move back and forth of those with a minimum of distraction, even if you had other windows. So just clicking on one window brought that document forward. To simplify context switching, there was a way of setting everything aside. And notice again the transitional animations. Let's see, where are we? Again, keeping with the document orientation rather than an application orientation, notice that there's no quit. There is a set aside and a save and put away, which are equivalent of close operations, but there's no quit. The desktop manager managed all the processes, so the user never started an application, they never quit an application. On the desktop manager would keep one version of a process around running, even if it didn't have any windows open. Most of the applications handled multiple windows at one time. But even if there were no windows open, it would keep a process running. And so when you went to open another document of that type, the process was already initialized, and all it had to do was open the document. The difference went from about 45 seconds doing an initial start up an application, that is, start up the process, initialize it, and open a document, down to around generally 10 to 15 seconds, which is still long. It's much too long. Even today, it's too long. But it was a terrific improvement in terms of the usability of the system and their perception, users' perception. As an aside, one of the things I'd like to show you is that we used something called placeholders. Most of you are familiar that when you open something from the desktop, it leaves some sort of graphic behind to indicate where it was. But the systems generally today don't leave anything inside of a folder to tell you where that belonged. So for example, if I take this and drag it out, notice there's still a place left for it. What this meant was that you could actually arrange things spatially, group them if you would, in a way that you liked them, move them to the desktop because you were working on them, and when you put them away, it actually went back to the same location rather than going to the first available location. It's a small thing, but it actually made spatial layouts useful. You can do that today, but it takes more work. Again, keeping with the document-centric nature of the interface, there was no new command in the menu, in the application, or in the menu either. In fact, there was no way to start an application without opening a document. To create a new document, there was stationery of various kinds, and you would use the same double-click action that you used to open it to create a new document. So, Dave, this is the answer to your question. We created stationery which you could not modify. And when you went to create a new document, it just tore off a new version, and you could open that up and use it. And you never, to give you an example here, I'm going to open the blank paper, and we'll create a new piece of stationery. Many of us don't need to use too many forms, at least that we create in our daily life, given the nature of the work that we do. I don't know, I'm assuming that. But there are a lot of people that do. So I'm going to take this. I assume this is a form that I've created, a template for something. And now I'll just point at it and say make stationery, please. And when this comes away, you'll notice the icon has changed slightly, and now it looks like a little stack of documents, and that was the indication this was stationery. And if you wanted to change it, you just create a new document, made the changes, and save that as stationery. I'm going to take this because I don't really want it, and I'm going to throw it in the trash can. We call it a wastebasket, actually. And what we did is, the reason for the wastebasket was to eliminate the problem of double delete. Delete this. Are you sure you want to delete this? Comes up the dialog, and you press the button and says, yes, I do. And it becomes a very automatic action, and what happens with a lot of dialogues that meant to protect you is the default action is, in fact, the unsafe action. And the result is, well, let me describe something that somebody mentioned to me. I won't mention the name today in a session. They wanted to empty the wastebasket. So they went to click on the wastebasket and say, empty trash. But they accidentally selected the a disk. And a dialog came up, and the dialog said, do you want to initialize this? And even as the hand reached for the return key, the person said, oh, this is a disk, I don't want to do this. But the hand had a life of its own. Bang! And they lost their disk. The wastebasket, we handle how to get things out of the wastebasket. What happens was, when you threw something into the trash, it removed from the trash what was already there. So it was kind of like a one-level undo. So there was no need to go up and say empty trash at some later time. If you look at the Macintosh system of today, they've actually created a triple delete. So you put something in the trash, and then it stays there until you say empty trash. And then when you say empty trash, it puts up a dialog and says, are you sure? They do make it very difficult to remove things. A thing we've tried recently in a new system is a timed delete. So things will stay in there for a period of time, maybe 2 days, but generally user settable. And the garbage collector just comes around, the janitor, comes around every couple of days and empties the trash. We didn't have a chance to do that. We didn't think of it. Otherwise, we might have done it. How are we doing? Okay. I'd like to talk now a little bit about the save model. In the star, every change you made was permanent. The document was always saved. It was a little bit like HyperCard, if you're familiar with that system that came along a little later. And as Dave said, unfortunately, there was no delete, so you couldn't even, or undo, so you couldn't even undo the last thing. We did have undo, but we put it in a menu, so if we didn't implement it, we could have taken it out. At any rate. So here's a document, and if we scrolled around, you would say, look, it's kind of a floor plan for a kitchen. Not too relevant. Here I'm going to, again, this is, noticeably different from the star, where you sort of had letter set type paste-its that you copied and pasted in. Here you picked up a tool and drew it, which is pretty similar to what most of you are familiar with today. So I've made a change. And my boss walks in and says, here, I want you to work on this, and he hands me a diskette. Now you don't say, well, nobody does that anymore, but we do have larger removable media now, things like zip drives and other things. So I'm going to go, and I need to free up my diskette drive, so I go to select the diskette, and I eject it. Now on a Macintosh today, it would say, I'm sorry, you can't do that. Something is in use, in parentheses. You guess what it is. Oh dear. I'll explain this in a moment. In a Windows system, it ejects the diskette. What we were going to see, and it didn't happen, was that actually the document would be automatically suspended and the diskette ejected. Let me try this once again. I have a feeling it's not going to work, though. My disk is probably corrupted. Okay, I guess I have to tell you, sorry this worked all day, so if you came this morning, you saw this happen. What happens is the diskette comes out, the window goes away, and the diskette comes out into your hand, and what's happened is that nothing was saved, but all the edits are persistent. Here I'm waving the diskette around, see it? Then when I finished, I would put when you were finished and ready to resume this, either on this machine or on another machine, you would put it back in. What happened is when the diskette was ejected, the document was suspended and all edits were written out to a suspend file, separate from the regular document. When I put this diskette back in, you would see the diskette reappear, the icon come out onto the desktop, and this window would open. And then some of the applications, the spec was that you could actually undo the last change you made, even after that. This one unfortunately didn't do this. Given what I've just seen, I'm not sure the following is going to work either. But what you could do, right, is you could say, you can see it here a little bit. Oh, I don't have the app. You could say revert to previous version. I'll probably be able to do this anyway. And so what you could do is you could remove all the changes you made since you last saved the document. Now, the system was designed to be robust. The applications periodically put out this edits file. Kind of an autosave, but it didn't overwrite your existing saved document. When the system was turned off, when a diskette was ejected, excuse me, the document was suspended. Here I'm going to do undo the changes, revert. It's been a while since I've used this, but it really is my system. And by the way, it was really 10 years ago. The Lisa clock stopped turning over in 1995. We don't have a year 2000 problem. So the idea here was that save was something you did when you wanted to because you had made a set of changes to a document that brought it up into a new consistent state. That was the only time you ever might have wanted to save, and it was actually you never actually had to save if you didn't want to, but then you couldn't revert. You did not have to save because you were paranoid. You did not have to save because you removed the diskette. You did not have to save because you turned the system off. That made revert useful because the last saved version was a version which you thought was consistent. Essentially, we had kept two versions of the document, the current working version and the saved one. And had we had time, we probably would have added a real versioning system that would keep them later. Now, where was that suspend file? Well, it turns out that the icons on the desktop are not disk files. The icon on the desktop is an object, and behind it may be 0, 1, 2, 3, and disk files. The user never dealt with disk files directly. What this did was it kept down the number of icons on the desktop. There wasn't a second icon for the suspend file. There was not a second icon for perhaps a lock file or something of that nature. The Lisa list program kept a disk file for each index into this flat file that it managed. You only saw one icon and you only dealt with one icon. And when you transferred something to another place, everything worked. You never had a chance of corrupting the object by accidentally removing or losing one of the disk files because of something you did accidentally. How are we doing for time? Okay. I'm going to tell you about something very briefly because we don't have much time. We use separate applications. We expected other applications to be written. So one of the things we wanted to do, oh, there's something from earlier editing. We used the clipboard and we defined several standardized data interchange formats. So for graphics, it was a picked file. There was text, there was tabbed text, which was a form of, which was tables. And virtually every application could copy its data as one of those forms. It would go on the clipboard, and you can paste it into virtually all of the other documents. So while it was dead in the sense that you couldn't edit it once you had transferred it, it did give us the ability to integrate virtually any kind of data type. Virtually is a word that says I'm lying, not every. There were a couple that wouldn't. Virtually every kind of data type from every kind of document to every other kind of document. So my Gantt chart, I could move from my project management and paste it into my Write document. We didn't have smart objects, but that was partly because we felt we didn't have time, and we were a multi-application environment. So that's a little bit about cut and paste and the clipboard and common data interchange formats. Lastly, I'd like to talk about another way that we tried to make the system simple. Let's start off, and we're just going to duplicate a document. And what we did here is had a duplicate command. We created a blinking icon which represented the duplicate that you were about to make. You could then take and drag it to and put it wherever you wanted it to be, rather than immediately duplicating it on the same storage, the same disk. We expected a diskette-based system. There might not have been room. And it also prevented kind of copying it once to the diskette it was on and then copying it again to some other place, so that's really where you wanted it. Now what this did is it kind of gave us kind of an ugly, what's happening here? Well, it thought I dropped, okay, that's the duplicate right there on the desktop, and it's on the same storage medium. And what this did is it gave us a way of doing a lot of other things. So for example, if that document was too large for the diskette, it would bring up a dialog and say, it's too large, would you like us to split it across several diskettes? Then you could say yes, and it would ask for diskettes in turn. You could back up the hard disk in exactly the same way. I'm not going to show you because it takes too long, as you might expect. But you would just say duplicate and drop it on a diskette, and it would come up with a dialog and say, do you want to back this up? Do you want to do a full backup or an incremental backup? And you would start doing the diskette dance again. If you wanted to duplicate a diskette, you would point to the diskette and say duplicate, and it would say, do you want to copy this to another diskette? You might copy it to the hard disk, is why it asked the question. And if you said yes, it would suck everything off of that disk, eject the disk, and ask for a new one, and when you put it in, it would write everything out. So this one duplicate action, this is in the style of star in some sense, was used to duplicate something, to make a copy somewhere else, to back up, to duplicate diskettes. And these were all built in. They weren't separate utilities in the system. These were things that the user did all the time. The user didn't have to know about running this utility or that utility. They just used the basic duplicate and copy actions. One thing I do want to say, the Mac takes a lot of heat for this. I'm going to drag this over to this diskette and drop it, and it's going to take a little while to do it. What happens is Lisa does a move. Now let's say I'm working on something and I wanted to give Rod a copy of a document. And I just sort of grab the icon and drag it over and drop it on the diskette. I'll pop out the diskette. That's why we fail later, there's not enough space left. I would take out the diskette, give it to Rod, and he would go off. And guess what? I don't have the document anymore. Because it was a move. Nice and consistent, but it creates an error situation which is really hard to recover from because Rod just got on a plane and took off for Florida. Okay? So while the Mac does an inconsistent mechanism, it works out a lot better because you don't have the error condition. So that's one of the reasons they did it. There were other things they did, and I'll talk to you afterwards, offline maybe, and we can talk about why they're good or bad. That's another issue. At any rate, to finish up, just to get to some questions here. We all stand on the shoulders of others, and we clearly stood on the shoulders of programs like Sketchpad, and I would say not enough on the shoulders of systems like Augment. Certainly Smalltalk and Star were part of the things that we stood on, and other systems stood on our shoulders. The Macintosh copied the interaction model. They copied the desktop metaphor. They did not copy our user model, however. What they did is they exposed the standard, traditional computing model underneath so that the users also dealt with processes, applications, and disk files. We tried to hide that. Star also did an extremely good job of hiding that. We hear a lot of people saying that today's systems are too hard to use. And we've been working at this for 20 years, so how come? Well, we need to make sure that we keep them simple. We can do that by, one, having more concise, more direct, simpler user models and sticking to them. We can do that by putting in built-in support for common operations such as the storage management and the context switching that I showed you. And lastly, we can clear out some of the UI cruft. We've developed a lot of different UI mechanisms over the years, and we don't really need all of them, although we tend to use most all of them now. So that's another thing. That's a pretty major step, though. We take a lot of heat when we change the UI. We take a lot of heat from our users. I'm sure you've had the experience. But at any rate, I'll say that if you want to see a system that uses some of these ideas, if you come downstairs to the exhibit area to the Sun booth tomorrow morning between, I think, 10 and 12:30, I'll be demoing a system called Hot Java Views, which is a user environment for an NC. And we used some of these ideas and with some of these kinds of simplifications, and you can take a look and see how a different user environment might look, designed to be quite simple. But at any rate, enough of that plug. Do you have any questions? Thank you very much.
There's a microphone in the aisle here, so we actually have several minutes for questions.
I'd like to ask, I guess I feel slightly guilty being part of the UI community, and, what have we been doing for the last 20 years kind of comes to mind. We've got color now, but, and I guess what I'm wondering is, you didn't say how big your software team was for the LISA. What was it? How many people?
30? I think it was about 30 people, including the operating system and all of the applications. There were generally 2 or 3 people per team.
Okay. I worked for a company that Frank worked for, also Taligent, before, and they had 300 people working on an operating system. And I'm just wondering if the difficulty and the problem and the bloat just comes from too many people working on a project. Can you, because, the Star had, what, 6 people?
No.
I just realized I completely misstated that. We had 300 people. We had 6 UI designers. There were 280 programmers and support people.
Okay. So what do you think might have stalled the progress in this area?
A lot of it has to do with backward compatibility. Our desire not to get the user angry at us in the immediate future because we changed something that they're used to doing. We try to be responsive to users, but it's not always necessarily the best thing to do. Sometimes we have to say no. There are some other issues. We had a pretty clean UI across and consistent UI across all of the applications, and that's primarily because the manager of the application group ruled with an iron fist with respect to the UI. This would have looked a lot more scattered had Larry Tesler not basically managed the UI in the way that he did. So it takes a very committed manager of this software team also to keep the UI consistent.
And I would also add that we had a very good model of who we thought we were designing for, and to that extent it set a number of constraints on what we could do and how we could iterate on the design and come up with different UIs for them. So there you have a very well-defined interface just based on a well-defined customer.
Dave wants to say one more thing.
Yeah, if you wouldn't mind just adding to the answer here. There's actually nothing about Star and Lisa that couldn't be done today. But it's going to take a whole different discipline. The easiest thing in the world is when you have a new feature, just make up a new command for the feature. But all that does is make your life easier and the user's life harder. So you've got to have the discipline to turn that around if you want to achieve this.
Oh, hi. I was trying to think. This question, I think, might be relevant to other people, and so I feel okay about asking a second question in the same session. And that is, let me preface it by saying the concern for the user shows through so strongly in both of these projects that you look at them and you think, how could someone seeing this not feel almost cared for in a special way? And how could these things, not be phenomenally successful? Those of us who work for profit-making or supposedly profit-making organizations, are instructed to measure success by the profit we make. And this, as someone who's done things in the past that have not made a profit either, this sounds a little like whining. But what can you tell us about the meaning of success and failure? Because there may be other people in this room who either have had similar experiences or will sooner or later in their careers.
I've got a comment. Well, first of all, one of the really rough things for both of these products was the cost. To get the first Star workstation in your company cost about $60,000. That's because it took a file server, a laser printer, which were really expensive at that time, and plus the workstation. The next workstation cost you $15,000. The incremental cost was smaller, but that first one was pretty hard. It was $10,000, which was still pretty expensive. When the Mac came out, it finally got down to a price where people could begin to think about it. So, but the original Macintosh, remember, I gave Mac kind of a hard time up here, but you have to remember, it had 128 bytes of memory and one diskette. It could not have done what we did. It simply could not. It needed the system support we had in order to implement this user model. In terms of the simplicity, so I think what killed our systems primarily was the expense. It didn't help for the Lisa that the Mac was rumored to come along 6 months later and it'd be just like the Lisa and cost only $10,000. So that was pretty hard too. I'm afraid I'm not directly answering your question, but I'm telling you why I think these products didn't succeed, which hopefully says other products that do try for simplicity do have a chance.
Well, I guess behind my question is maybe these products are wild successes, but we weren't using the terms properly, or maybe there's more than one kind of success.
Fred Brooks, in his Mythical Man Month, said be prepared to throw one away. Those of us that were working on the Lisa didn't realize we were working on the throwaway. However, the Mac did pick up our interaction style and at least picked up the metaphor. But at each of these stages that you've heard about today, Augment, Star, and the Lisa, there were things that got dropped in the process of making the product something that could be afforded. And I think it's worthwhile to occasionally go back and look at the systems. Normally what got carried forward was the visual stuff. What got dropped was the stuff that was hard to see.
Thanks.
First, I want to say thanks. There were great presentations, real impressive work that was done, and I feel lucky to have seen the last ever Star demo ever. With that in mind, I have a historical, non-technical question about both. I'm curious where the name Lisa and Star came from.
Star was just the last internal name that we had before it was time to ship the product.
And the Lisa was actually an internal name as well that we all liked so much. By the time that the product shipped, we used it. We came up with an acronym for what Lisa meant, and that was Locally Integrated Software Architecture, which was a mouthful to say and really meant nothing, but that's really where the name came from.
Was Lisa the name of Larry?
Was not the name of Larry Setz's daughter, no. And I will deny other rumors about whose daughter it was, or whose girlfriend it was, or whatever, but that folklore is actually true.
But I got there too late to know.
Yeah.
Thanks. For sure.
Last question?
So my question goes both to Lisa and Star. I was wondering if in your design, you considered tiling windows.
I'm sorry?
Tiled window manager?
Tile?
Yes, versus overlap, which was a great issue 10 years or 15 years ago.
Well, tiled windows really requires a large display screen. It's completely infeasible on a smaller screen. So that's first off. In fact, if you remember back to Windows 1.0, it was a tiled window system on a PC screen, and it was a total flop. The reason we went to a tiled window scheme was in our studies of people like using the Alto computer, which had overlapping windows, we noticed that a lot of them spent a lot of time and effort getting the window overlapping just right. And anybody who looks at a Windows system today will see the same thing. So we said, well, let's just divide up the screen for the user. And it actually didn't work all that badly. If I had to do over, I don't know that I would do tiled again, but it was an idea that was motivated by the user's concern, and I don't know that it was a total success.
Yeah. Well, to an extent, we wanted to deal with the person who had to move back and forth between tasks very quickly, and having to look at our screen and the size that it was meant that we really wanted to have as much use of that screen real estate in the high-resolution graphics as possible. So we really wanted to make use of the full screen and let the people then organize the screen the way they wanted. And using overlapping windows plus the clipping scheme that Frank described allowed us to very easily get the front window displayed quickly, and then the back windows would fill up as necessary.
Just to put in another plug, if you come down to see the demo tomorrow in the Sun booth, Views was a full screen. That is basically, it wasn't tile, it was a full screen application, again, because it's a small screen. We took a lot of heat for that. Users at this point, whether it's in their best interest or not, that's what they want. So that's what we'll give them.
Well, I think we all have been very lucky to get to share this afternoon with you all, so thank you very much. We really appreciate it.